Now we'll come to the last part, that is carboxylic acid. Carboxylic. First you need to understand the word. That is carbonyl group plus hydroxyl group. Together it is called as carboxylic group. So you know the functional group of carboxylic is COOH. This is the functional group. And the general formula of carboxylic acid is RCOOH. This is the general formula of carboxylic acid and the functional group is only this much, COOH. Now how do we get COH? Now see, this is your carbonyl. This is called carbonyl, CARBONYL, carbonyl group. And this is your hydroxyl group. This is hydroxyl. We can say that. Together we get it what? We get it carboxylic, COOH. What is this called as? Carboxylic group. So it is said to be as. So carbonyl group plus hydroxyl group, we get it carboxylic group. But this does not mean, let me tell you, that carboxylic acid contains the properties of alcohol, and this particular group, where we get it in aldehydes and ketones. It contains the properties of both alcohols and aldehydes, ketones. No. Just for the namesake, I've said you this one, this particular thing. You need to understand that. So in this way, this is your carboxylic group. So if carboxylic group starts from the, what you can say, compound is HCOOH. This is called as methanoic acid because one carbon, methanoic acid, or common name is formic acid. Formic acid, the word has come from red ant. When the red ant bites you, alright, then there's some itching and burning sensation is there. You know why? Because it stings. Not only the red ants, then that is ants, wasp, when it bites you, there's a burning sensation is there, the itching is there, redness is there. Got it? Because the stings leaves formic acid in your body. Got it? For that reason it happens. So it has come from the Latin name formica. Formica means ant or the wasp, we can say that. So from there we got the name formic acid. Got it? It has come from the Latin name formica. Alright, because the source of this acid is your ant, wasp and all these things. So that the meaning of the formica is, that is nothing but is your, we can say ant, red ant, we can say that. Red ant, white ant, or as wasp, we can say that. So hence we call it as formic acid. Now similarly, the next in the category, next in the series is, you just add CH2 group to it. I always say, so CH2 and H is what? CH3. So CH3COH is what? It is your vinegar. Vinegar or acetic acid or ethanoic acid. IUPAC name is ethanoic, 2 carbon, ethanoic. Similarly, you add another CH2 group. What you will be getting? CH3, CH2, COOH, propanoic acid. In this way it goes on. Propanoic acid. Clear? So in this way, vinegar or the Latin name is acetum. For that reason we are calling it as acetic acid. It has come from the Latin name, that is acetum, and from there we have got it acetic acid. Clear? So in this way, this is a source from where we are getting. The source is your vinegar and the Latin name is acetum, and hence the name is called acetic acid. We can say that. Clear? So if you see, acetic acid is a fatty acids. Got it? Not acetic acid basically. The higher carboxylic acid is considered as fatty acids because it's a source for fats and oils. From there we prepare fats and oils. We will be reading in higher classes about it. That is we are getting it from the fermentation of sugar. Like suppose any fruits, when it gets fermented means kharab ho jata. Alright, what do you find? It turns sour. Alright, what is that? That is acid. Clear? That is acid. We can say that. It has gone sour means it is, the fruit juices now contains acid. Basically, that is acetic acid and all these things, we can say that. So main, we are getting acid, the carboxylic acid from the plant extract we are getting it. So this is a source of carboxylic acid. We can say that. And also the main source of acetic acid is known as vinegar. Already I said it. We can say that. So carboxylic acid containing one COOH group is called as monocarboxylic acid. One COOH group. So these all are mono carboxylic acid. Formic acid, acetic acid, propanoic acid. These are all monocarboxylic acid. Similarly, we can also have 2 COOH group. Alright, 2 COOH group. So if 2 COOH group is there, then it's said to be as what you can say, dicarboxylic acid. If 3 COOH group is there, then we can call it as tricarboxylic acid. If 3 COH group is there. Alright, if 2 it is, then di. For example, let me give you an example to you. That is COOH, single bond COH. It is called as oxalic acid. Oxalic acid. You know, it is found in tomatoes. Oxalic acid. This one is. Similarly, if it is CH2, this is dicarboxylic acid. T, 2 COH group is there. CH2COH. Similarly, that is COH. Then COOH. And another one CH2COOH. This is called as citric acid, which is found in lemon. We can say that. This is tricarboxylic acid. Tricarboxylic acid, we can say that. Alright, this is having 3 COH group present in it. 2 COH group, that is this one. Just an example I gave it to you. Okay, fine. So in this way, we got the different names of the carboxylic acid and from where we got it, what is the source, I said it to you. Alright, now next we'll come to the preparations. Already I said it just now to you. That is, when alcohol is oxidized, we get aldehyde, unstable product. And aldehyde, when it's further oxidized, it gives you carboxylic acid. Got it? I already discussed with you. Now, next is from the hydrolysis of ester. Got it? I just told you esterification, isn't it? So, CH3COOC2H5. If I go for hydrolysis, HOH. Got it? Clear? In presence of H+, that is acidic medium, then what will happen? Cl. Now you will be getting C2H5 and it goes with OH to form C2H5OH, and what we get it? CH3COOH. See? CH3COOH plus C2H5OH. We get it. This is acetic acid and this is your alcohol. So in this way we can prepare acetic acid. This is called as hydrolysis of esters. Hydrolysis I have said you, replacement by OH group, and that OH group we can get it from not only water, we can get it from NaOH, you can get it from KOH, you can get it from calcium hydroxide, you can get it from ammonium hydroxide. Alright, in this way, from wherever you are getting OH, replacement by OH group, alright, and removal of any other group. When OH group will replace another group, that group will be removed, isn't it? So hence that is called as hydrolysis, and this is known as acidic hydrolysis, so to say. And this is called as ethyl acetate or ethyl ethanoate. It's an ester. Now you will find that acetic acid is a colorless liquid having a not a pleasant smell, I should say that. It is having a smell, a characteristic smell, we can say that smell of vinegar, a pungent smell. It is miscible with water, it is miscible with alcohol as well as with ether, we can say that. Organic and inorganic solvent, we can say. Polar or non-polar solvent also we can say that. Water is a polar solvent and alcohol, ether, they are the non-polar solvent, we can say. It has got a boiling point of around 118 degrees centigrade, got it? And pure acetic acid, remember this sentence, pure acetic acid, which forms an ice-like solid. Got it? Pure acetic acid or anhydrous acetic acid, which forms an ice-like solid. When it is cooled below 16 degrees Celsius, we can say that. It crystallizes and it forms an ice-like solid. Got it? That is called as glacial acetic acid. What is that? Glacial acetic acid. Glacial, because it looks like glacier. Pure, what I said, acetic acid, anhydrous acetic acid, when it is cooled below 16 degrees Celsius, it forms an ice-like solid. That is called as glacial acetic acid. We can say that particular one, pure, it should be pure, and for that reason I said it is not anhydrous, because if you add water means it becomes hydrated, then it is not pure, isn't it? Okay, fine. So in this way, acid, if you see these are physical properties, then acid, if you see, it reacts with base to form salt and water, we know that. For example, CH3COOH, when it reacts with NaOH, what is going to form? Salt. CH3COONA plus water. This is known as sodium acetate plus water. Similarly, it will react with KOH to form CH3COOK plus water. Similarly, it reacts with calcium hydroxide to form CH3CO whole twice Ca. Suppose I'll write it here, calcium hydroxide, calcium, CaOH whole twice. So what will I get? CH3CO whole twice Ca. Finished. Got it. So here I'll take this much plus water, I'll be taking it. So rather you will be getting 2 molecules of water also, balance it. So it is calcium acetate, similarly you get magnesium acetate. Similarly, if you take here ammonium hydroxide, NH4OH, you will be getting CH3COO NH4. Ultimately, that is what I said, it will react to form salt and water. Acid plus base reacts to give salt and water. So to say. Clear? Now, next is, after that, if you see, it reacts with sodium carbonate, CH3COOH plus Na2CO3. Got it? So what is going to form? It is going to form CH3COONA plus H2O plus CO2. Actually, it forms carbonic acid. It forms carbonic acid. Carbonic acid is unstable. It decomposes to give you carbon dioxide and water for that reason. So in this way, if you take here sodium bicarbonate, alright, you will be getting again same thing, sodium acetate plus water plus carbon dioxide. Now you need to balance this one. You will be getting 2 CH3CONA because Na2 is there, na? So in this way. So in this way, you take sodium carbonate or sodium bicarbonate. If you take here NaHCO3 here, NaHCO3. Alright, let me take here NaHCO3. What I am going to get it? Don't need to take 2 here. No need to take 2. It will be CH3CONA plus water plus carbon dioxide. Done it is. Okay, finished. So in this way, it reacts with sodium. Already we have seen it. It reacts with alcohol chapter. It reacts with sodium like CH3COH plus Na. Simply sodium. CH3COOH plus Na when it is heated will give you CH3COONA plus hydrogen gas is released. Alright, here also same thing, hydrogen gas is released. Simply if you take magnesium also here, metals like Mg or potassium or calcium, you will be getting corresponding salt and hydrogen gas will be released. For example, if you take here Mg here, magnesium, then what I am getting? I will be getting CH3CO whole twice Mg plus hydrogen gas is released. We can say that. Similarly, already we have studied esterification. Alcohol reacts with acid in presence of conc H2SO4, reversible reaction to give CH3COC2H5 plus water. This also is a test for carboxylic acid because it gives you a fruity smell. Esters have fruity smell, good smell. We can say that. You know, esters where it is used in all the flavoring substances, in ice creams, in chocolates, in everywhere. In cake, we are using an essence we are putting. That is nothing but known as esters. Nowadays, in medicines also you can see the essence is coming. Mango flavor, banana flavor, orange flavor, that flavor. What is that flavor? That is nothing but is your esters. That flavor is nothing but is your esters. Alright, that's essence. We can say that. Clear? So in this way, test for acetic acid is that is acid reacts with base to form salt and water. Also, acid reacts with alcohol to form esters. And also we have got another test, you may write it down, note it down. When acid, carboxylic acid, let us say acetic acid, reacts with neutral FeCl3, it gives you a wine red color. When acetic acid reacts with neutral FeCl3, neutral ferric chloride, it gives wine red color. It is also a test for acetic acid, we can say that. Similarly, when acid reacts with PCl3, just like in alcohol I said, it is going to form CH3COCl and H3PO3. When acid reacts with PCl3, CH3COOH plus PCl3. CH3COOH plus PCl3 will give you CH3COCl plus H3PO3. Similarly, CH3COOH plus PCl5 will give you CH3COCl plus POCl3 plus HCl. Again I repeat, CH3COH plus PCl5 will give you CH3COCl plus POCl3 plus HCl. Remember it. Whenever any organic compound reacts with PCl5, it gives POCl3 and HCl as a compulsory product. Similarly, any organic compound reacts with PCl3, H3PO3 is a compulsory product. In previous case in alcohol also I said it, H3PO3 if you remember it. Alright. Now similarly, acetic acid when it is heated, it gives acetic anhydride and water. It gives acetic anhydride. See here, CH3COOH, 2 molecules when it is heated, will give you CH3CO whole twice O plus water. This is called acetic anhydride or ethanoic anhydride, we can say that, and water. Similarly, when acetic acid is reduced in presence of nascent hydrogen, it gives ethyl alcohol and water. When acetic acid is reduced, alright, where should I write? I am writing it here. That is CH3COOH plus nascent hydrogen. Nascent hydrogen will get it from reducing agent. Let us say LiAlH4 will take reducing agent, or zinc slash HCl we can take as reducing agent, or we can take that is sodium in presence of ethyl alcohol. Alright, or zinc copper couple in presence of alcohol. Many things are there. I have written with that one, you can see it. So when acid is reduced, see, just go back. When alcohol is oxidized, it gives aldehyde, aldehyde to acid. Na? So come back. Acid on reduction will give aldehyde. Aldehyde on reduction will give alcohol. Why not? Aldehyde is a stable product. Why not aldehyde we get as a product? Because aldehyde is not a stable product. Alright, aldehyde, why the reaction does not stop there? When acid is reduced, we should get aldehyde. On reduction, yes, but aldehyde is not a stable product. So aldehyde is further reduced to alcohol, C2H5OH plus water. So you can balance it. You will see you will be requiring here 4 nascent hydrogen. You will see that. Clear? In this way, you will be getting, that is, acid on reduction with any reducing agent like lithium aluminium hydride, LiAlH4, zinc/HCl, zinc in presence of hydrochloric acid, sodium in presence of ethyl alcohol, Na/C2H5OH, zinc copper couple, Zn-Cu/alcohol will give you nascent hydrogen. All these are reducing agent. Will give you alcohol. On reduction will give you alcohol. And alcohol and uses of acetic acid, already I have said you, it is used for preparation of esters, it is used for the preparation of acetone, it is used for coagulation of rubber, coagulating rubber, we can say that. It is used for the preparation of phosphorus oxychloride, we can say that. It is used to what you can say, it is used to dissolve phosphorus, sulfur, iodine, we can say acetic acid. In the manufacture of vinyl acetate, which is used in the preparation of resins, in the preparation of acetic anhydride, alcohol, so many things we are getting it. In the preparation of hydrogen, got it, so many things we can say that. Clear? This is all about. Thank you.